Okay, we can start from this part in the word atom. What does word atom mean أصلا? It means that is the smallest part found in nature, or you can say it is the uh, building unit of matter يعني, that is not divisible, undivisible. خلاص. فatom, it is a two-part word. A means un,
Mm-hmm.
okay, and atom, the pen is not full. هي يا جدع. خلاص. A means un. خلاص.
Mm-hmm.
With Tom means divisible. So we can say that in atom means the undivisible part. It is the smallest unit. This is what is called an atom. خلاص. طيب.
Mm-hmm.
But we have different atoms. Not all the atoms are the same. طبعا you can say that, but we know that in the atom can be divided into protons and neutrons and electrons وكده. هقول لك this is correct. But proton itself will not do what the atom do. يعني if you have a proton, you cannot know this proton is from an oxygen atom ولا الهيدروجين atom ولا الكلورين atom. This is بيبقى insignificant part. As if you have the human cell مثلا, and you took the mitochondria of this cell. You can say that the mitochondria is the building unit of the human body. Our ribosome, our nucleus of a human cell is the building unit of a human. لازم تقولي إن the cell itself as a whole is the building unit of a human body. That goes for an atom. The atom itself as a system with its nucleus and its protons, neutrons, electrons. The cell, the atom itself is the building unit of a matter. But atoms differ from one type to another type. يعني the atoms of sodium is completely different from the atoms of chlorine, of iron or كده. That's why we call each type of atoms an element. تمام؟
Okay.
يبقى element is just a word that means this is an atom, but for يعني a certain type of an atom. This is a sodium. Sodium metal has many properties. والله الهيدروجين atom has many properties. Iron. An atom is considered to be يعني ايه building unit of the matter, and we have different atoms for different types of substances, so we call them elements. تمام؟
Elements are different types of atoms.
صح كده. الصوديوم element غير الكلورين element but both of them are atoms.
Mm-hmm.
طب حلو. If the atom comes together with another atom to form a bond, يعني
That
I have
creates
a
a
hydrogen and an
molecule.
oxygen and a hydrogen. These are three different atoms. تمام؟ Binding with each other to form ايه بقى؟
A molecule.
A molecule. يبقى الموليكيول is a bigger unit. الموليكيول is يعني ايه more than one atom forming a structure. It can be of the same atom. يعني sometimes chlorine binds with itself. One
Mm-hmm.
chlorine atom with another chlorine atom having a covalent bond between each other, they form a molecule of the same atom. مش إشكال. المهم إن هم طالما more than one atom, therefore we call them إيه؟ We call them a molecule. For
Mm-hmm.
simplicity, we can call it a molecule, but يعني إن شاء الله we will يعني differentiate between the ionic compound and the covalent compound, because when I say مثلا ال NaCl, it's not يعني we do not say it is a molecule, we say it is a formula unit. يعني it's different from a molecule for covalent compounds and formula units for ionic compounds.
Mm-hmm.
خلاص. طيب Uh, now we want to know what is the structure of the atom itself. يعني هنا بنتكلم على what did Dalton say? He said that in all matter is composed of tiny undivisible parts called the atoms. تمام? Atoms
Mm-hmm.
cannot be created nor destroyed. And this is funny because this is يعني this is very important in the belief in God يعني a law of
Mm-hmm.
conservation of mass and the law of conservation of an energy. Mass is neither created nor destroyed. تمام. الانرجي is neither created nor destroyed. تمام. يعني يعني this بس ايه this يعني good sentences needs to put our God in this sentence. يعني except for
Yeah.
God no one can make up an atom.
Mm-hmm.
Except for God no one can destroy an atom.
Mm-hmm.
You cannot make a thing nothing. You
Mm-hmm.
cannot. You can change it from a solid to liquid to gas. You can change it from an electric energy into يعني light energy, but you cannot destroy energy. You cannot
Mm-hmm.
destroy matter, and you cannot form it. You cannot form
Right.
it. And they believe that يعني something came from nothing, and that's weird.
Yeah.
Like,
The Big Bang Theory.
uh, where did the rock come from يعني where did the exploded matter come from يعني المهم atoms of the same element خلي بالك ده كلام برضه دالتون atoms of the same element are alike in every way and this is يعني a mistake that we will deal with يعني
Mm-hmm.
because certain types of atoms of the same element can be different in mass. This is what is called the isotopes. We will talk about this يعني later on. يبقى هو said ايه بقى؟ matter atom cannot be created or destroyed. The atoms of the same element are alike in every way. Atoms of different elements are different. Nitrogen is different from carbon is different from كذا. Atoms can combine together in small numbers or to form molecules, and this was the first time to represent this idea.
Mm-hmm.
يعني scientists thought that مثلا in the water is made up from atoms of the water. Before
Mm-hmm.
Dalton, they didn't know that in a water molecule, it consists of two different elements came together to form a molecule.
Mm-hmm.
But he was the first scientist to introduce this idea يعني in ال atoms combine together to form molecule. فطبعا this is what we call بقى الكومباوند. طيب. The first thing that they did discover طبعا الموديل that was given by Dalton for an atom was a very simple and it was يعني most of it was wrong يعني Dalton thought that in an atom it's just a solid sphere and what is meant by solid and it has no spaces inside it. You know the
Mm-hmm.
difference between the football and bowling ball او البلياردو
Yeah.
البول of البلياردو it has
Yeah.
something inside it. If
Right.
you take this bowling ball and you hit someone with it, you would kill him. Because
Yeah.
it has no air inside it. It's filled with matter. فدالتون thought that in the atoms are like that, solid spheres, homogeneous. There is no difference between the matter of يعني this matter inside the atom. Then another scientist came, which was Thomson. Thomson was the first one to discover. You know what is the first part of the atom was discovered?
Oh, what part?
Electrons.
The electrons?
Electrons was the first part of the subatomic particles to be discovered by Thomson. طبعا coincidence. هو كان شغال on الجازز and it was a time that they discovered the electricity. So they used the electricity to do everything. يعني they tried so many experiments on electricity. Let's get a man and electrify him. Let's get a chicken. Let's get a rabbit. Let's get a piece of wood, a piece of iron, a piece of something. Let's try to electrify the gases. So they found that the gases are very bad conductors of electricity. So they
Mm-hmm.
started to change the conditions of the gases. So Thomson was the first was dealing with the gases and the conductivity of the gases. So he put the gas, certain gas in a tube called the electron discharge tube, like that.
Mm-hmm.
خلاص. And we have the gas inside it كده. And this is a vacuum tube. They took all the air from the tube and they put one of the gases inside the tube. So the gas now is under very low pressure. And they يعني tried to enhance the conductivity of the gases by trying to increase the voltage of the electric current that will go through this tube. When they reach a certain يعني amount of the voltage, يعني it was like 10,000 volts أو حاجة زي كده, a very high voltage with a very low pressure, certain types of rays started to appear, moves from the cathode, which is the negative electrode, to the anode, which is the positive electrode. So they called it cathode ray. And I will not بقى يعني I will not go into details يعني. This
Mm-hmm.
experiment was the experiment that made Thomson say that electrons are found in each and every type of element in this world. So the electrons are considered a fundamental part in any type of matter. Okay, so the first one to يعني to discover a subatomic particle was Thomson, and he discovered the electron. But when he introduced the model of the atom, يعني Dalton model, it was like this, just a solid state.
Mm-hmm.
Thomson introduced a model which it's برضه another solid sphere. تمام, هو قال دالتون عنده حق, it is a solid sphere. But this solid sphere is made of positive something, and negative particles are embedded in this positive something. طب يا عم تومسون, you did discover the negative part. What is with the positive part? Why did you say that an atom has a positive part and negative parts are embedded inside it, are put inside it? Because they thought, and they were right, an atom must be electrically neutral. The atom
Mm-hmm.
must be electrically neutral, because if the atom was positively charged or negatively charged, this means that the matter is positively charged or negatively charged. So we would find many يعني many awkward things, like مثلا ايه, if we try to shake our hands together, we will repel from each other, because you are negatively charged matter and I am negatively charged matter. أو مثلا if you are walking beside the wall, you will be attracted to the wall. You will get stuck to the wall because the wall is positively charged matter and you are negatively charged matter. But we know that this is not happening. That's why most of the scientists agreed on that, in the matter is electrically neutral. So the atom must be an electrically neutral structure. Like, I know that I have a negative part in the atom. Thomson was positive. He was the first one to discover the negative part. So he suggested that the atom is a positive matter, like a dough, and the
Mm-hmm.
electrons are embedded inside this dough, like the plum pudding dish. يعني you have a pudding dish or plate يعني, and you are putting plums inside it. This was the model of Thomson. they call it a plum pudding model, or they can call it a chocolate chip model. The dough
Mhm.
is the positive substance, and the
Mhm.
chocolate chips are the negative edge. خلاص؟
Okay.
دي طبعا it was the first step to understand the structure of the atom. Then Rutherford came and he did some experiments on the atom, and it was a breakthrough because Rutherford did يعني discover that in most of the atoms, and Thomson was wrong about the solid sphere substance, and Dalton was wrong about this part. He discovered that Rutherford discovered three things actually. Uh, first of all, in most of the atom is an empty space.
Most of an atom is an empty space.
اه يعني he did do an experiment with the gold foil. This is a gold foil, a very thin foil of gold, and he started shooting this gold foil with what is called the alpha particle.
Mm-hmm.
If the atom طبعا the alpha particle is a very very tiny particle يعني okay. If the gold foil if the alpha particle يعني reflected from the gold foil, this means ان الايه ان the particles الالفا particles يعني collided with something and reflected back صح كده and bounced back. It's like hitting the wall and bounce back from the wall صح.
Right.
Rutherford observed that most of the alpha particles went through the gold foil as if the gold foil was not there.
Mm-hmm.
You know the net of the goalkeeper for football.
Yeah.
This goal that he is defending, it has a
Mm-hmm.
fence صح كده. It has a net. طيب try to يعني to throw something small through this net. Most of the small balls will go through the net, will يعني will go to the other side, will penetrate without deflection or reflection or أي حاجة. That's what happened بالظبط مع الجولد فويل with الالفا بارت. يعني if you have like if you have like 10,000 particles مثلا 9,990 particles went through a gold foil without changing its path ولا deflection ولا reflection ولا أي حاجة. So
Mm-hmm.
he suggested that in gold atoms and most of the elements are like that يعني are made up of things a huge
Mm-hmm.
أو a tremendous أو بيسموه إيه a very huge uh, volume of space. And he noticed that some of the alpha particles reflected a very small amount of the alpha particles reflected from the gold foil.
Mm-hmm.
That made him يعني concluded that there is a certain tiny part inside the atom that is considered uh, a very dense piece of substance. Most of the atomic mass is concentrated in this part. So he discovered the nucleus inside the atom. يبقى الأتوم is a very large space with a nucleus inside it. And then he found that some of the alpha particles did go through a gold foil, but it deflected. So
Mm-hmm.
he suggested that in the nucleus inside the atom has the same charge of an alpha particle. So when some of the alpha particles moves near the nucleus push it away. This means that an alpha particle has the same sign of the same charge of the nucleus. So his third uh, يعني part of his theory that in the nucleus inside the atom contains positive charged matter. So now we can say that in as Thomson said, inside the atom there is a positive something, but he didn't know where the positive matter was. Rutherford did discover that the positive matter was inside a tiny piece of matter inside the atom called the nucleus. يبقى Rutherford discovered in the atom is empty space, and there is a nucleus inside this empty space, and this nucleus is positively charged.
Mm-hmm.
And he knows from Thomson's experiments that the electrons are moving around this nucleus. Okay, till
Okay.
Rutherford, now we can say that this is the experiment that he did. شايفة? Most of
Yeah.
the alpha particles did come through the bulk foil, and some of it deflected. شايفة الديفليكشن حصل ازاي؟ الالفا بارتكل كان ماشي كده، then the nucleus pushed it away, so the alpha particles deflect. And some of the alpha particles collided with the nucleus and bounced back. Okay? يعني
Mm-hmm.
to cut it short, now we know that in an atom is made up of a nucleus inside a very vast space, and the nucleus is positively charged, and the electrons are moving around the nucleus. Electrons are moving around the nucleus like Earth and the other planets are moving around the sun.
Mm-hmm.
طيب وبعد كده they started to to study a nucleus. They found that the nucleus is made up of two things, the protons and the neutrons. And now we can say that inside the atom we have a nucleus. A nucleus has two parts, neutrons وبروتون، وبعد كده في الكترونز ماشيه في الانرجي ليفل. اوكي I think we are going slow، احنا ماشيين على الهادي خالص، صح كده؟
Yeah.
The neutrons and the protons are inside the nucleus, so we can call them together. This name is given to the neutrons and the protons. We can call them collectively nucleons.
Mm-hmm.
Why did we say nucleons? Because they are inside the nucleus, and the electrons are moving around. طبعا البروتons have positive charge, والelectrons have a negative charge, والneutrons have no charge. تمام كده؟
Okay. تمام.
The particles are described by their relative masses and charges which with no units. The absolute masses and charges of these fundamental particles are given in section 4 في البوك data. هو بيقول لك here we can say that the relative mass of the protons and the neutrons is 1. And the relative mass of the electron is 0.0005. So
Will it always be like this, or is it just like depends on the element?
لا, it does not
So the
depend.
protons.
The number
Sorry?
of the protons and the neutrons inside the element will make the element will give the element its mass. So elements have different masses because they have different amounts of protons and neutrons. But for the neutron and the electron and the neutrons, protons, electrons, and neutrons, they have this constant masses and charge. البروتون الريلاتيف ماس بتاعته ب1، النيوترون 1، so they are almost the same. But the neutron is slightly heavier than the proton. خلاص؟ And the electron is considered nothing if compared with the protons and the neutrons. So we can neglect the mass of an electron.
Mm-hmm.
Okay? When we are dealing with the
Mm-hmm.
masses of the atoms, we will not take into consideration electron forms.
Mm-hmm.
But if we're dealing with the star, the protons and the electrons are the most important. تمام؟
Okay.
then force come بقى. يبقى احنا كده خدنا ايه؟ دالتون، الاتوم is solid sphere. بعد كده تومسون، والله في شويه negative something inside this solid sphere. بعد كده Rutherford, it was a breakthrough. Rutherford, the atom is an empty space. It has a nucleus inside it, and the nucleus has a positive charge. بعد كده later on Rutherford برضه discovered the protons, and يعني one of the scientists, I think his name was okay, his name was Chadwick or something like that, discovered the neutrons. النيوترونز المهم يعني Gilbert يعني Rutherford did not know how the electron was moving around the nucleus. That's what ايه بقى that's what Bohr did. He did give us a model of a hydrogen atom. He failed to do or to explain any other element يعني atomic spectra, and we will deal with the atomic spectra يعني later يعني. But
Mm-hmm.
Bohr discovered, we can say that in Bohr discovered the principle of energy level. In the atoms, each atom has different energy levels, and the electron is rotating around the nucleus in these energy levels, and these energy levels have different energy, خلاص, and the electrons can move يعني from top from the lower energy level to the higher energy level if it is excited and so on يعني. فهو بيقول هنا Bohr pictured the hydrogen atom as a small solar system with an electron moving in an orbit or energy level around a positively charged nucleus. The electrostatic force of an attraction between its oppositely charged subatomic particles prevents electrons from leaving the atom. And the atomic, so most of the volume of the atom is empty space. يعني we have ايه؟ electrons are negatively charged and it is moving. خلاص؟ الprotons are positively charged. The attraction forces between the protons and the electrons is what is preventing the electron from moving away from the atom. حلو الكلام؟
Mm-hmm.
طيب نفس الكلام inside the nucleus itself, neutrons are very important for the stability of the nuclei. طب why? Because if I have a nucleus with more than one proton, المفروض ان هم they will repel. يعني if I have مثلا a sodium atom with an 11 proton inside of a very small area or very small volume اللي هي nucleus,
Mm-hmm.
المفروض ان هم يحصل بينهم repulsion. The presence of the neutrons inside the nucleus is a very important part of keeping the nucleus stable and not making the protons يحصل لهم mutually repel each other. تمام كده؟ طيب الاتوم contain a positive charge خدناها، negative charge خدناها، use the nuclear symbol كذا كذا كذا. relative masses and charges of the subatomic particles should be known خدناها. actual values are given to the data booklet. actual خد بالك I'm reading from the side of your teacher. actual values are given in the data booklet اللي هي ان البروتون ب1 والنيوترون ب1 خلاص.
I thought maybe he was talking about like the values of like the elements of like the atoms, like the value of
لا مش كده. he's talking about the subatomic particles. The actual values are given in the data booklet because the mass of the proton is 1.0008742 مش عارف ايه 33 والmass of the neutron you will find it 1.00876 مش عارف ايه and the neutron is slightly heavier than electron. بس to keep it simple يعني لحد ما نوصل للمسائل اللي احنا ممكن نحتاج فيها الماسز of البروتونز and النيوترون. We know that in the relative masses 1 بالبروتون 1 بالنيوترون والالكترون has a negligible mass. Structure 1.3 what determines the different chemical properties of the atom. Structure 3.1 how does the atomic number relate to the composition of the elements in the periodic table. طيب. Now we will talk about ايه بقى this symbol. Now we want to differentiate between each and every element. So
aren't these like different isotopes?
لسه بقى الخطوه الجايه isotopes. فاحنا بس ايه الاول هنتكلم عن different elements. Each element has a symbol صح؟
Mm-hmm.
So we will deal with any element. So we will say that let's say that the element is X. Each and every element has two numbers. A number is put in the upper left side. خلاص. This is called the mass number. طب الماس نمبر ده refers to ايه بالظبط الماس نمبر ده؟
It refers to the weight of the atom,
ايوه which we can get it from
the periodic table.
that. From the number ها خدي بالك الماس نمبر هيجي من النمبر of the proton plus the number of the neutron because we know that in each proton is 1 and each neutron is 1.
So why not the electrons?
حلو السؤال ده ووحش السؤال ده في نفس الوقت. Why not the electron؟ هقول لك خلاص let's weigh the electron يبقى النمبر of the electron. طب تعالي بقى لنفرض ان I have an atom like this
Mhm.
sodium. Sodium has 11 protons. So I will put 11 times 1. Okay? And it has like 12 neutrons. So I will do this 12 times 1. And it has 11 electrons. صح كده؟ So I will do 11 times 0.0005. This value compared with the number of protons with number of electrons, it's like that you are doing a diet, and I'm saying that your eyelashes is very heavy.
Mm-hmm.
If I remove your eyelashes, does it make a difference with your body weight?
No,
It won't make a difference, صح كده?
right?
In spite of having a certain mass. That's the electron compared with the proton and the neutron.
Mm-hmm.
So we can neglect, if we're talking about a mass number, forget about the electron. The electron have no significance because it has a very small mass.
Mm-hmm.
خلاص كده؟ فكل
Hold on.
تركيزنا هيبقى على ايه؟ دايما وانا بتكلم على الماس نمبر يبقى السيجنيفيكانت فيجرز بتاعتي البروتونز والنيوترون. خلاص؟
Mm-hmm.
طيب.
خلاص.
What about the Z? The Z
It's the atomic number.
this is the ID. This is the identification number of any element. So different elements can have the same mass number عادي مفيش مشكله. We will talk about this في الايزوتوب. انما ما ينفعش يبقى فيه two different elements with the same atomic number.
فمش فاهمة الحتة دي.
يعني دلوقتي ماشي I have a nitrogen and a carbon. حلو الكلام. Nitrogen is 7. الاتوميك نمبر بتاعها 7. It has 7 protons.
Oh,
الكربون
okay.
it has 6 protons.
Okay.
If I put a proton inside the carbon, it will change into nitrogen.
So the atomic number is the amount of protons it has?
أيوة. طبعا amount of
Oh,
proton
okay.
or electrons بقى المرة دي. Because we know that in each atom has the same number of protons and electrons. خلاص؟ طيب.
Either going to be showing the amount of protons or
What
the
about
amount of...
the neutrons بقى؟
No, because neutrons
Neutrons is
can't
not
be the same.
has no significance when we're dealing with the atomic number because it has no charge and the atomic number is important for the charges او electric state بتاعت الاتوم. ولكن sometimes طبعا الماس نمبر of a neutron is 14. Okay?
Okay.
Because the nitrogen has 7 neutrons with a 7 protons. Some of the atoms of the carbon may contain 8 neutrons.
And that's an isotope.
One of the isotopes of the carbon.
Right.
We'll deal with the isotope in details دلوقتي. طيب تعالي بقى نشوف عندي 8 neutrons و6 protons. So the mass number of the carbon can be
14 as well.
يبقى mass number can be the same for two different elements. But the atomic number, لا, it will never be the same. ما ينفع.
So atomic number can never be the same. So atomic number can never be the same?
The atomic number can never be the same. Never, never, ever. If you take a proton from a nitrogen, it becomes a carbon. It's not nitrogen anymore. Okay? طيب. يبقى تاني هنقول X is the symbol of the element. A is the mass number of the element, protons plus a neutron. V is the number of the protons, which is the atomic number. But how to get the number of a neutron from the atomic number or mass number? We can subtract an atomic number from a mass number. This will give us the number of the neutron.
So mass number minus atomic number equals electrons. Okay.
Equal A?
Electrons.
لا. الماس نمبر minus الاتوميك نمبر يديني النمبر اوف الالكترونز. لا. يديني
number of neutrons.
Neutrons.
So how do I find the electrons then?
The electron, any atom has the same, its total number of the protons must be equal the number of electrons. Because the atom is electrically neutral. So if I have 10 protons, I will have 10 electrons. 11 protons, 11 electrons. طبعا before بقى before undergoing the chemical reaction. تمام كده؟ يبقى احنا خدنا ايه؟ الماس نمبر. We know now الماس نمبر. We know الatomic number and we know how to get the number of mean of a neutron. This is an example of aluminium 13 is 27. بصي sometimes periodic tables differ. يعني sometimes he writes الالومنيوم كده يقوم جاي مره حاطط 13 هنا و27 هنا، ومره يكتب الالمنيوم كده، تلاقي الالمنيوم كده وحاطط الايه ال 27 فوق وحاطط ال 13 تحت. المهم يعني دايما السمولر نمبر بيبقى الاتوميك نمبر،
Mm-hmm.
واللارجر نمبر بيبقى الايه
The
الماس.
larger number is the
اللارجر نمبر
mass.
is the mass number.
Mm-hmm.
Okay, if I have this example يعني aluminium 27 13, this means that a number of a neutron inside the aluminium is كام؟ is 14.
It's 14.
سهل الكلام.
Yeah.
طب النمبر of electrons
Number of electrons is also 13 because protons and electrons are equal because it's a neutral charge.
ساعات ساعات او مش ساعات، ده most of the elements if you take a look في البريودك تيبل مثلا كده
Mm-hmm.
بتلاقي ايه مثلا كلورين 17 فوق، شايفه هو كاتب فين فوق 17 فوق، المفروض ال 17 دي ايه تتكتب فين؟ تتكتب تحت هنا كده، بس انا بقول لك sometimes يعني ايه زي يعني change places يعني. المهم انا عندي هنا 17 و 35.45. مين الاتوميك نمبر بتاع كلورين؟ السمولر نمبر، تمام. ومين الماس نمبر بتاعي؟
Mm-hmm.
الايه اللي هو اللي تحت ده 35.45. طيب مستر دلوقتي how come ان 35.45 this means that ان chlorine has like 18.45 newton. Where did the 0.45 newton come from?
Oh, it's from the different isotopes and they combined it
Ah,
together.
بالظبط بقى. We have this relationship that we will deal with right now to get the relative atomic mass. Relative atomic mass. Why? Because مثلا sometimes let's talk about the carbon. A carbon is, has an atomic number 6. طيب الكربون has different types of الاتوم. Sometimes الكربون الماس نمبر بتاعه بيبقى 12. Sometimes 13. Sometimes 14. ف
Mm-hmm.
if I wanted you to get the average of these mass numbers هتقول لي يا مستر this is easy. We've done this many times in math. هناخد 12 plus 13 plus 14 over 3 كده.
No, isn't it that you have to know like the percentage average of each of them and then you
ممتاز
multiply them together, then you add
ممتاز
them all?
ممتاز، لان انت لو عملت الافريج زي الماث كده هيطلع الافريج بتاعك ب 13. هقول لك برافو عليك 13. The problem is الكربون 12 ده is like 95% abundant. يعني 95% of the carbon are carbon 12 and مثلا 4% of the carbon is carbon 13 and 1% is carbon 14. So it is very unfair to say that in the relative atomic mass بتاعت الكربون is carbon 13 كده. طب where did the 95% حقوق الانسان بتاعتهم راح، الهيومن رايتس بتاعتهم راحت فين؟ The majority is not represented in this periodic table. So
Right.
what to do بقى? To get the relative atomic masses, we will try to find the contribution of each isotope. But what is the isotope? What is meant by the isotope? The isotope is a phenomenon of
Could
ايه
you
بقى؟
come a bit closer to the microphone because it's a bit hard to hear you?
والله
Yeah.
غريبة قوي. طيب تمام كده. One second.
Mm-hmm.
Is it better now?
Oh yeah, it's better now.
طيب I'm using an old-fashioned mic. Sometimes I need to change its battery.
Hmm.
Now it's fine صح كده؟
Yeah, yeah, yeah.
طيب كويس. Okay. What is the isotope? What is meant by isotope? Isotope is a presence of different atoms of the same element. Okay, we are talking about the same element. Different atoms of the same element having the same atomic number, of course, because we cannot play with the atomic numbers. Okay, having the same atomic number,
Mm-hmm.
but it has different mass numbers.
So same atomic number but different mass numbers.
بس خد بالك ايه احنا بنتكلم على ايه يعني different atoms of the same element.
Mm-hmm.
يا رب. I think
Okay.
I need to upgrade many things خلاص خلاص. فبيقول لك ايه to have different mass numbers the atoms must have different numbers of neutrons. We have no يعني if I ask you طب how come same atoms have different masses? The only thing that can be changed is the neutrons.
So neutrons can vary between the same
يعني I
element.
have مثلا الصوديوم مثلا كده 11 11 but ده sodium 23 ده sodium 24. So what's the difference between the two? The
The
first sodium has a 12 neutrons and the second sodium has 13 neutrons.
Mhm.
So the different numbers of neutrons inside the nucleus can make this phenomena. This is what is called the isotopes. تمام؟
Mhm. تمام.
سؤال بقى سؤال. What is the difference between الisotopes؟ يعني what difference does it make ان ده يبقى صوديوم 12 صوديوم 23 وده صوديوم 24؟ Does it have anything to do with the chemical properties of an element? No.
It has the neutron.
واحدة
Never
واحدة.
mind. Wait.
خدي بالك النيوترونز neutral ف it will not affect the charge of the atom. اوكي؟
Okay.
الchemical properties هنا بيقول لك ايه isotopes show the same chemical properties. Why?
Oh,
Because
because neutrons have no charge, no effect.
مش على كده مش الفكرة. ما هو خدي بالك المغنيسيوم والصوديوم هما الاثنين are chemical are electrically neutral but they are different في chemical properties. الchemical properties يا دورة depend on a number of اللي هو الاتوميك نمبر ده بس not for the protons بقى. الchemical properties is dependent on the electrons. What is meant by chemical properties? losing electrons gaining electrons. Do I lose electrons ولا do I gain electrons ولا do I share electrons? Okay. Do I react with the hydrogen with the water vigorously ولا لا؟ كل ده is electron dependent.
Mm-hmm.
Depends on the electrons. 90% of the chemistry is dealing with the electrons.
Mm-hmm.
Isotopes have the same electrons. يعني this sodium atom and this sodium atom. These are two different atoms, two different isotopes of sodium. خلاص.
Mm-hmm.
How many electrons does the first one have?
The first one has
Electrons.
12.
These are the neutrons.
Oh, so neutrons? Oh, it has 11. Sorry, it has 11.
الالكترونز في الفيرست one 11 وفي السكند one
11.
11 برضه. طب الالكترونيك ديستريبيوشن هيبقى عامل ازاي؟ 2 8 1 سواء في الفيرست one أو في السكند one.
Right.
Both of them will lose this electron in the chemical reaction. Both of them will make a positively charged positive one cation. خلاص. So there is no difference in the chemical properties between the isotopes. Isotopes differ in the nuclear chemistry part only. Nuclear chemistry. Okay? This is a very special part of the chemistry, dealing with the nuclear reactions inside the nucleus, not dealing with the electrons with chemical reactions. تمام كده؟ فيهمنا ان احنا نعرف ان الايزوتوبس have the same chemical properties. فين تليفونك؟ على الترابيزه، حطيه في الشحن. محدش يمسك تليفونك خالص. يلا ما دوري عليه. يلا يلا. طيب how to get بقى we have now different chlorines. chlorine 35 وchlorine 75 37. طيب how to get relative average relative mass of these isotopes. بيقول that this value is closer to 35 as there are more chlorine 35 atoms in nature. It is the more abundant isotope. In a sample of 100 chlorine atoms, there are 77.5 atoms of a chlorine 35 and 22.5 atoms of a heavier isotope, chlorine 37. To work out the average, what do we do بقى؟ بيقول لك we first have to calculate the total mass of 100 atoms. ها؟ التوتال ماس of 100 ايه؟
Atoms.
طيب التوتال ماس of 100 atoms we have the mass of one atom اللي هو 35.45. فالتوتال ماس سوري انا اسف ال 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 we have a 77.5 with mass 35 and 22.5 of mass 37.
So those are the abundances.
احنا كده يعني هنجيب هو بيقول لك ايه how to get relative atomic mass. Do these steps. رقم واحد, if I have 100 atom 77.5 منهم هيبقى وزنهم 35.
So
اوكي
that's like 77.5%.
ها
That's 77.5%. So if like we're
يعني
dealing with
بالظبط كده. And 22.5 atoms which had a mass of 37, so the total mass of the 100 atoms will be 35.45 3545. الريلاتيف افريج ماس equals بقى التوتال ماس divided by number of الاتومز فهيطلع ب 35.45. This is one way of calculating it. يعني if he is giving you the percentage abundance, you can say that ان الماس اوف الكلورين مثلا 35 انا هضربها تايمز 77.5 over 100 بلس 37 الوزن الثاني times 22.5 over 100. These are called the abundances. خلاص؟
you're just على طول instead of doing 77.5 you just do 0.775 multiplied by 35.
ممكن عادي مفيهاش مشكلة.
Okay.
The two isotopes are both atoms of chlorine with 17 protons, 17 electrons. Although both isotopes essentially have the same chemical properties, the difference in the mass does lead to different physical properties, such as the boiling and the melting points. Heavier isotopes move more slowly at a given temperature, and these differences can be used to separate الisotopes. يعني بيقول لك ايه؟ بما ان الماسز are different يبقى talk to me about physical properties, not the chemical properties. Okay? And a way that can be used to separate between different isotopes. You can use الديفرنس in الماسز بتاعتهم او الموفمنت بتاعتهم. الهيفير اتومز موف slower than اللايتر اتومز. State two
Mhm.
physical properties other than a boiling point and the melting point that would differ for the two isotopes of الكلورين. طبعا الدنسيتي، اي حاجه بقى اربطيها بالماس. يعني ايه الفيزيكال بروبرتيز اللي ممكن تفرق بين تو ايزوتوبس؟ ما انت لو بتتكلمي على different masses خلاص يبقى اكيد مثلا الدنسيتيز are mass dependent. يبقى هتكلم على ايه؟ على الدنسيتي.
Mhm.
اوكي، يبقى انا كده عندي melting points و boiling points are different. وفي بقى النيوكلير ستابيليتي، بس دي عايزه بقى فيلم تاني. النيوكلير ستابيليتي ان some of the isotopes are stable و some of the isotopes are not stable.
Why is that?
Because sometimes the nucleus cannot hold uh, the ratio between the protons and the neutrons is very important for the stability of atom.
Mhm.
As the neutrons, as the ratio between a neutron and proton, the difference between them increases, this makes the atom uh, is very unstable. That's why الكربون 14 is used في الكربون dating of substances, because we use the radioactive carbon 14. الريشيو in الكربون 14 is 8 neutrons to 6 protons. This means that in the ratio between the neutrons and protons 8 over 6, it's like 1 point كام 1.33 مثلا. This is a very large ratio for the small atoms. يعني for the small atoms to be stable, the ratio between the protons and the neutrons should be 1. كل الكلام ده هندرسه في النيوكلير كيمستري، فيعني ايه.
Mhm.
Let's stick to the plan. Explain why relative atomic mass of tellurium is greater than the relative atomic mass of iodine even though iodine has greater atomic number. تفتكري ليه بقى؟ تعالي كده نشوف الكلام ده. Explain why the relative atomic mass of tellurium is greater than the relative atomic mass of iodine even though ان iodine has a greater atomic number.
Wait, can you say that again?
Explain why the relative atomic mass of tellurium is
Mhm.
greater than the relative atomic mass of iodine even though iodine has a greater atomic number.
Um, Maybe because okay, so we're talking about atomic number. I mean, sorry, atomic mass. So that means we're talking about the ratio between protons and electrons. I mean, sorry, protons and
Neutron.
neutrons.
ايوه.
Yeah. So maybe the reason why deuterium is greater than iodine is because of it has greater protons
لا greater،
compared.
لا greater number of neutrons بقى. ما هو بيقول
No.
لك الايودين has atomic number greater than التليريوم، مع ان التليريوم عنده ماس نمبر اكبر. يبقى اكيد الموضوع كله مرتبط بايه؟ related to ايه؟ to the neutrons. يبقى اكيد التليريوم عنده الايزوتوبس of التليريوم has more neutrons than الايزوتوبس of الايودين.
So why not protons?
ما هو لو
Is
بالبروتونز الايودين، ما هو بيقول لك explain why the relative atomic mass of التريليوم is greater than الايودين even though ان الايودين عنده greater atomic number. يعني we know that ان الatomic number of الايودين is greater than التريليوم.
Oh. Okay, فهمت.
اوكي ماشي. الايونز he didn't talk about الايونز.
Um,
ثواني عشان بس ما نبقاش ناخد حاجة مش وقتها.
So he was mostly
الisotopes are atoms of the same كذا خدناها.
the gas laws.
Perform calculation involving a non-integer relative atomic mass and the abundance of isotopes from given data. Differences in the physical properties of isotopes should be understood. ها الديفرنسز in the physical properties of isotopes. لو بنتكلم على different properties يبقى احنا بنتكلم على ايه؟
The different neutrons.
لا لما اقول لك physical properties يبقى هتكلميني عن ايه؟ عن الميلتينج بوينتس، عن البويلينج بوينتس، عن الدنسيتي. These are called the physical properties. دايما لما تتكلمي عن physical properties يبقى forget about the chemical reactions. لما اقول
Mm-hmm.
لك ان الايزوتوبس have different masses, this means that in they have different melting points, they have different boiling points.
Mm-hmm.
الatoms of the heavier isotopes move slower than the atoms of the lighter isotopes. Okay,
Mm-hmm.
there is a difference in the density between the isotopes because the density is a mass dependent property. ماشي ولا ايه كده؟
Could you say that part again, please?
ايه يا دورة، النهاية نايمة ولا ايه النهارده؟ حاسك مش مركزة.
لا مركزة.
طيب، هو احنا مش قلنا ان اي حاجة في الدنيا ليها two different properties؟ في chemical properties يبقى I am talking about the reactions. اوكي؟
Mm-hmm.
طيب
Okay.
الchemical properties is strongly related to the electrons only. That's it.
Okay.
طيب on the other hand ال substance الماتر يعني different matters have different physical properties. طب what is the physical properties بقى؟ The most important physical properties boiling points melting points. Because
Mm-hmm.
by knowing the boiling points melting points we will understand the changes of the matter from solid liquid gas or gas solid. ها we need the melting points and boiling points if we want to understand the physical changing of the matter. مش كده؟ طيب
Right.
sometimes
استنى بس ماما اتكلم السوبر بالليل بقى التاني.
اضحك عليا بس ماشي. اقفلي باب وراكي. على طول اخدين موبايلاتي. اوكي نكمل. فاحنا بنقول ايه؟ خلاص الكيميكال بروبرتيز على فكره I am ايه concentrating on the things that he is uh, putting in his tables يعني. فهو هنا بيقول differences in the physical properties of the isotopes should be understood. That's why I'm trying to make this clear. When we're dealing with physical properties, most of the physical properties are mass dependent. Okay?
Mm-hmm.
Depends on the mass, not the number of electrons. So if I have two different chlorines with two different mass numbers, two different isotopes, the melting points and the physical points will not be the same. The melting points or boiling points.
It won't you can't find like the relative
I
atomic.
don't, he's not asking you to find the relative أو average boiling point أو melting point. He just wants you to know that if you have, what's the difference between the two isotopes? Okay,
Mm.
so if he asks you this question, you must know what's the difference between the isotopes. What difference does it make to know that in the sodium 23 there is a sodium 23 and there is a sodium 24.
Mm.
فبنقول we يعني till now عشان بنتكلم على الجزئية بتاعتنا we are not talking about the nuclear chemistry, we are not talking about the radioactivity.
Mm-hmm.
If we want to talk about the physical properties of the isotopes, we will find they have different physical properties, but same chemical properties. Why? Because the chemical properties depend on the electrons. The chemical properties depend on the electrons. electrons gained, electrons lost, electrons shared. Okay. الphysical properties is more dependent to the masses. Heavier substances are different from lighter substances. So
And so how do we know like the physical properties? I don't really understand that part. Like how do I know if it's like lighter or if it's heavier or if it melts faster or if it melts slower?
you don't have to know if it melts faster or if it's melt slower, but you
Like
must
it's
know
melt
that in different isotopes have
Mhm.
different masses. With
Okay.
different masses means they have different melting points and boiling points. He will not ask you about give me the melting point of the chlorine مثلا 35 and the chlorine 37. He will not ask you
Okay.
this question. He just wants you to know that they have different physical properties. طيب ما انا لازم ابقى عارف اصلا give me an example of the physical properties.
Mm-hmm.
حتى هنا بيقول لك في الهامش هنا بيقول ايه a common error is to misunderstand the meaning of a physical property. A
Mm-hmm.
difference in a number of neutrons is not a different خدي بالك a difference in the number of the neutrons is not a different physical property. A physical property a physical property of a substance can be measured without changing the chemical composition. That's the meaning of the physical properties. Measuring
So
measuring measuring a property of a substance without changing its composition. بمعنى ايه؟ I have in H2O liquid.
right.
Okay. By boiling the water till 100 degrees Celsius, it
Mm-hmm.
is still H2O, but now it is a vapor. So I can get the boiling point of the water without changing the H2O. This is a physical property.
Mm-hmm.
Okay. I can get the density of a liquid by using a hydrometer without changing its composition. This is a physical property.
Mm-hmm.
So melting points خلاص بقى حط بقى في دماغك كده physical properties, melting points, boiling points, الdensities, الcolor, الodor, الappearance. اوكي
Wait, I
كل
just
الحاجات
have
دي
a
كل الحاجات
question.
دي بيسموها physical properties.
Mm-hmm. I just have
They
a quick question. That physical properties, are they like manipulated or they depend on like the mass? Like they depend on the mass number, so basically the amount of neutrons within it, but the neutrons isn't a physical property. I understand that, but it's the amount of neutrons affecting the physical property. I just want to make sure that I got that right.
طيب ما هو خدي بالك انا دلوقتي عندي كلورين وعندي كلورين او خليني كربون وكربون كربون وكربون ده عنده 6 بروتونز وده عنده 6 بروتونز
Right.
بس ده عنده 6 نيوترونز وده عنده 7 نيوترونز.
It would be 12 and 13.
طيب ده 12 وده 13. This isotope is heavier than this isotope.
Right.
صح كده؟
صح.
طيب ده they have the same volume كاتوم as an atom they have the same volume.
Mm-hmm.
اوكي طيب الدنسيتي equals الماس على الفوليوم. Both of them have the same volume. Let it be 10 مثلا. فانا عندي او let it be 100 مثلا. اوكي فانا عندي one of them الماس بتاعه 12 والفوليوم بتاعه 100 and the other one الماس بتاعته 13 والفوليوم بتاعه 100.
Mm-hmm.
So the densities will be different.
Will the volume always be in 100 or is it just
let it be انا بقول لك let it be. عايزه ايه؟ موبايل نور اهو. اما اخلص من موضوع الموبايلات ده امتى مش عارف. خلاص كده انا بقول لك let it be. To understand it they have different densities because atoms have same masses same volumes اسف but they have different masses. So this means in one atom will be denser than the other.
Okay.
Is this bad? Is this يعني do you think it's hard?
No, I think I get it now. I think I get it now.
أكيد.
Yeah.
Okay. طيب forget about the numbers. يعني make sure that you know in the physical properties as processes melting, boiling, condensing, evaporating, sublimating كل الحاجات دي بتبقى physical processes يعني. طب as properties بقى يبقى I am dealing with the melting point, the boiling points, ال appearance, ال hardness, density اللي هي الحاجات I do not have to change. يعني if I give you something tell me about this metal مثلا هتقولي والله this metal is malleable, this metal is ductile. اوكي يعني it can be shaped. اوكي طيب and this non-metal it cannot be shaped, it is brittle, it can be broken easily. If I have a piece of chalk and I break it down, the chemical composition of the piece of chalk أو ال substance inside the chalk will change.
Mm-hmm.
I'm asking you a question. If I have
Oh,
this piece of chalk and I break it into two pieces,
okay.
does this change its chemical composition?
No, the chemical composition is only based on the electrons. So it's only changing its physical properties.
بالظبط كده. So البريتلنس، الهاردنس، الدكتيليتي، الماليابيليتي، الابييرنس، شايني، دال، كل الكلام ده بنقول عليه فيزيكال ايه؟
Properties.
فيزيكال بروبرتيز. طيب يرجع مرجعنا للتيتشر. ايه هي تيتشر؟ ايه تاني عندك؟ relative masses and charges مش عارف ايه the mass مش عارف مين isotopes what determines the different chemical properties of the atoms. طبعا chemical properties
We're
of
gonna
atoms
see
يبقى
the amount of
electrons.
electrons.
ايوه الالكترون صح كده. structure how does the atomic number relate to the position of an element in the periodic table excluded. بعد كده isotopes خلاص. in nature of science reactivity 3.4. how can isotope tracers provide evidence for a reaction mechanism. come on, are you going through in nature of science.
أنا عارفة, I don't know.
Differences in the physical properties of isotopes should be understood. Specific examples of an isotope need to be learned. ايه بقى specific examples of an isotope need not. طيب ما زي الفل انت والله. طيب how can isotope tracers provide the evidence of a reaction mechanism. ما دخلناش على الماس سبكترا. دخل على الماس سبكترا ابن الذين ده. ماشي. طبعا احنا معانا كمان Sunday صح؟
Yeah, Sunday. And we also have that one class that we missed, so we could try making it up before the test.
حاضر. ده انت محوشة بقى. حاطة في الصندوق. طيب اوكي I'm trying to ايه يعني I'm trying to go through each and every single word that he is saying
Mm-hmm.
scientists in two isotopes كذا and كذا one key stage in
Command F.
المagnetism project.
Do command F and then like type some keywords that might take you there. Like tracers, command F tracers.
I'm trying to find like ما هو nature of science اصلا يعني هو he is saying that in ده كل ده في slide 1 nature of science reactivity مش عارف ايه how can isotope tracers provide the evidence of مش عارف مين. اهو بصي هنا بيقول radio isotopes are used in nuclear medicine for diagnostic treatment and research as tracers.
So radioactive isotopes, does that mean like unstable isotopes?
Yes.
Okay.
I
Tracers.
will give you an example على حتة بتاعت how can isotope tracers provide the evidence for a reaction mechanism. And so the isotope could be separated. Isotope enrichment is employed in many countries as part of a nuclear energy. لا 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 لا. I will give you. بص يا دور.
Mm-hmm.
Useful nuclear مش عارف ايه. طيب let's say مثلا ايه مثلا يعني in الفوتوسينثيس okay الفوتوسينثيس is carbon dioxide plus H2O and sunlight to give C6H12O6 زائد O2. This is glucose طبعا اوكي تمام معايا.
Yeah.
طيب I have a question. If I want to know the oxygen produced from photosynthesis, does these oxygens come from the carbon dioxide which the plants use from an atmospheric air, or it comes from water that the plants absorb by its roots from the soil?
It comes from both.
Or both. This is a third choice.
Mm-hmm.
I'm not asking you to answer. What do scientists do to understand the mechanisms? They start using radioactive isotopes of oxygen in a carbon dioxide. يعني they start preparing carbon dioxide samples using
Mm-hmm.
oxygen 14. سوري oxygen 14 ايه بقى oxygen 18. هو الاكسجين عنده 3 ايزوتوبس 16 17 18.
Okay.
خلاص oxygen 18 has a radioactive property.
How do I know if it's radioactive?
هتقولي لي why يا مستر؟ هقول لك because ان the number of the neutrons inside the oxygen is much higher than the number of the protons, so the nucleus becomes unstable. These details are not يعني you do not have to know all these details يعني ولكن all you must know that in I can get a radioactive oxygen. Okay? This
Okay.
means that it produces kind of radiations. Because of its instability, it produces certain type of radiations, radioactive radiations. Yeah.
Mm-hmm.
So I will play a game. I will use the radioactive oxygen to form a sample of carbon dioxide. And I will use this radioactive carbon dioxide with the water from a natural source. يبقى I know that ان الاكسجين اللي جوه الووتر 16.
Mm-hmm.
And using certain instruments called Geiger counter, we use a Geiger counter to measure radioactive levels يعني خلاص كده. So
ما
by
فهمتهاش
ها
أوي.
قول.
I didn't really understand it that well.
انا لسه ما قلتش حاجه.
طب
انا لسه ما قلتش حاجه. انا بقول لك I will use two different samples of carbon dioxide والwater.
لا كنت بقول على ال radioactive isotopes, like how do I know if it's radioactive or not?
For you, you will not know. يعني it needs يعني to make certain calculations. يعني الأكسجين مثلا I know that إن الأكسجين عنده 8 protons خلاص كده. عنده 8 protons and النمبر اوف النمبر الماس نمبر بتاعه 18. this means ان هو عنده 10 ايه؟
Neutrons.
10 نيوترونز. انا لو حطيت ال 10 over 8 it will not give me 1, it will give me 1.2 مثلا. This is not a good sign of instability. For small
Okay.
atoms like the oxygens and the carbon, I need the ratio between the protons and neutrons to be 1. So since the ratio between the neutrons and the protons, they call it a neutron-proton ratio. Since the ratio is more than 1, is much higher than 1, okay, this means that the nucleus is unstable and it will show some radioactivity.
Is this also the same if the neutron-proton ratio is less than 1?
Yes, but this is a very rare case. To find the number of neutrons is less than the number of protons. Okay? طيب فهعمل ايه بقى؟ هشتغل بتو سامبلز، نورمال ووتر وراديو اكتيف كربون دايوكسيد. And I will try to measure the reactivity of the produced oxygen. If I find that all the oxygens that I have is radioactive oxygen, this means it comes from a carbon dioxide.
Okay, فهمت.
اوكي، وبعد كده second step عشان اجاوب على الثيرد تشويس بتاعك هقوم جاي عكس. هشتغل الكربون دايوكسيد 16 والووتر 18 الاكسجين بتاعها. If I find that ان الاكسجين produced has a radioactivity, this means فعلا زي ما دورا قالت ان الاكسجين comes from both. طب if I find that ان الاكسجين is natural oxygen, there is no radioactivity in the oxygens that is produced from photosynthesis. This means that ان الاكسجين comes from الكربون دايوكسيد فعلا، بس لان هو لما الكربون دايوكسيد كان نورمال بقى نورمال اكسجين، لما كان راديو اكتيف بقى راديو اكتيف اكسجين.
Okay, فهمت.
This is what is meant by ايه بقى؟ using tracers. These are the tracers اللي هو carbon 14 oxygen 18. These are called the tracers because we can trace them using certain instruments زي الجايجر كاونتر كده, which makes tick 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 tick. If it finds it's like the movies, he's doing this with an instrument tick 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 tick. This is a radioactive substance. tick 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 tick. هو ده العداد جايجر. اوكي فهمتي؟ This
Yeah.
is called using بقى الايزوتوب traces to understand the mechanisms. خلاص؟ طيب.
Basically, it means that tracers means using radioactive isotopes to see where which product elements came from the reactants.
بالظبط كده. يبقى ايه how can isotope tracers provide evidence for a reaction mechanisms by using radioactive isotopes? We can determine which products come from which reactant.
Okay.
اوكي طيب وبعدين هيبدأ بقى يتكلم على الايه الهاير ليفل اللي هو الماس سبيكترم. طب you know about الايونز الكاتاين والاناين والكلام ده صح؟ Before
I know that.
we leave this part يعني ان دايما an atom an element has the same number of protons and neutrons. Okay? if the atom أو element loses electrons, we cannot call it an atom anymore. خلاص. You
It's an
cannot say that it is
anion.
an atom. It is an ion.
Mm-hmm.
And the ion must have a charge. And the charge depends on, did this atom lose an electron ولا gain an electron? If it loses an electron,
It's an anion.
it's a cation.
Oh,
And it has
cation.
a positive value, a positive charge. خدي بالك. The chemistry is the only science that losing something give you positive charge.
Mm-hmm.
I'm losing,
Right.
but you are losing a negative thing. So a positive charge will be achieved على ال elements that loses. خلاص كده او will be put يعني على elements that will lose electrons. والعكس بقى. Gaining electrons means and the number of negative parts is more than the number of positive parts. So by gaining electrons, we will find that in the element changes into an ion. طبعا positive ion is called the cation
Mm-hmm.
and the negative ion is called an anion. The element radium was first discovered by مش عارف Marie Curie. She is the only person to win Nobel Prize in both physics and chemistry. الله الله. The Curies were a remarkable family طبعا يعني. واحدة عندها physical وكيميكال نوبل هتبقى عاملة ازاي يعني. For scientific honor, Marie shared her first prize with husband Pierre كمان and her daughter Irene shared hers with her husband. الله 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 الله. ده انتوا عيلة معقدة بقى كلكم. ماشي. كلكم نوبل برايزرز. نوبل برايز winners. طيب. This is an easy يعني ايه an easy exercise. You can do it as a homework.
Mm-hmm.
I will give you some time to take a screenshot.
Okay, got it.
طيب. بعد كده we have like 10 minutes to go. We can talk about ال relative atomic sorry ال mass spectrometer as an introduction يعني. وبعد كده we can deal with this on Sunday.
Okay.
احنا كده خلصنا انا عايز بس اشوف السكند سلايد هيبقى فيها ايه.
The fourth slide is mostly what interested me because it's about like gas laws as
والله
well as
الجاز لوز احنا عاملينها مع بعض كلها. البي
yeah, but I
والبي
still
والان والار والتي وكل الكلام ده حاضر. I'm بس I'm trying to cover الايه ال النيو
yeah.
بس. counting particles moles ماشي masses of atoms compared on a scale relative مش عارف and expresses as relative ماشي we've done this. molar masses والempirical formulas. خلاص slide 2 we're done with slide 2. molar concentrations خلاص ال concentrations احنا خدناها.
Mm-hmm.
والايديال جازز هدوس لك على الايديال جازز لحد ما اخليهم لك ان ايديال.
Okay.
How are chemical equations used to calculate the reacting ratios? Okay. Include the use of state symbols in chemical equations. The more ratio. ماشي. ratios ماشي. reacting ratios. masses يعني. limiting reactants. طب خلاص. احنا كده يعتبر الجزء الوحيد اللي ما عديناش عليه في الحتة دي اللي هو ماس سبكتروميتر ده.
Mm-hmm.
ناخده مع بعض ان شاء الله يوم الاحد. و most of the other things are done يعني. وشوفي الحاجات اللي انت بقى يعني use a pen كده ولا you can write it down يعني. اي حاجة تحس انك مش عارفاها في ال other slides we can do
Okay.
it. ما فيهاش مشكلة خالص. طيب تعالي نتكلم بس as a beginning كده او يعني an introduction في الحتة بتاعت الماس سبكتروميتر ده. بيقول relative atomic masses of some elements. An instrument known as a mass spectrometer can be used to measure the mass of the individual atoms. The mass of the hydrogen atom is كذا and the mass of the carbon atom is كذا. As the masses of all elements are in the range من كذا لكذا, and these numbers are beyond our direct experience. It makes more sense to use relative values. The mass needs to be recorded relative to some agreed standard. A carbon is a very common element which is easy to transport and store because it is a solid. Its isotope C12 was chosen as the standard in 1961 as discussed in chapter 1. ماشي كل ده relative atomic mass is كذا. Relative atomic mass of carbon is كذا. Carbon 12 is the most abundant isotope of carbon, and carbon 13 and carbon 14 also exist. This explains why the average value of an element is greater than 12. ماشي يا ريس، عايز ايه؟ الماس سبكترا. هنا بيقول the results of the analysis by the mass spectrometer are represented in the form of a mass spectrum. The horizontal axis shows the mass per charge ratio of the different ions on the carbon at 12 scale, which is in most cases can be considered equivalent to their mass. The percentage abundance of the ions is shown in the vertical scale.
So wait, what's the mass charge? I understand the abundance, but not like the mass charge. Is that the electrons? Or what's it talking about?
Mass spectrum of gallium, the number of lines indicates the number of isotopes, 2 in this case. The value of the x-axis indicates their mass number, and the y-axis shows the percentage abundance. هو يعني mass per charge دي he is considered it الماس يعني هو بيقول لك ايه الفيجر 2.6 mass spectrum of الجاليوم. النمبر اوف اللاينز بيindicate النمبر اوف الايزوتوبس. اوكي يعني if I have 2 lines this means I have ايه 2 isotopes.
Oh, okay.
اوكي ال 69 وال 79 ده الماس of each isotope. The horizontal axis shows the mass per charge ratio of the different ions on the carbon 12 scale.
Would this be given to me, or would I have to find like the mass charge
لا
ratio?
هو النقطة نقطة ايه؟ يعني he will give you the graph and he will ask you about the graph.
Oh, okay.
يعني he will give you the graph like the graph in the figure وبعد كده he will ask you something. طيب the percentage abundance of ions is shown on the vertical scale. تمام. The mass spectrum of gallium shows that in a sample of 100 atoms يبقى دي حتة البرسنتج abundance. يعني طالما احنا بنتكلم على percentage you will find that in these lines are making percentages. If you add them together you will get 100. يعني the first isotope is a 60% abundance والsecond isotope is a 40% abundance. If you
Right.
add them 60 plus 40 هيديك 100.
Right.
ماشي؟
ماشي.
طيب هنا بيقول the mass spectrum of gallium كذا shows that in 100 atoms 60 have a mass of 69 and 40 have a mass of 71. We can use this information to calculate the relative atomic mass of the element. يبقى what is needed to be known that using the graph can help us to find الايه relative atomic mass. اعمل ايه؟ اضرب 60 times 69 plus 40 times 71 يبقى I am getting the total mass of 100 atoms.
Okay.
بعد كده اقسم على 100 اللي هو العدد بتاعهم to get the average. يبقى that was not hard. يبقى الماس سبيكترم هو عبارة عن x axis ده طبعا النمبر اوف اللاينز ده النمبر اوف الايزوتوبس. ادي حاجة. الحاجة الثانية الاكس اكسس represents الماس of each isotope والواي اكسس represent الابundance بتاعهم. So we can use الايه these two information to get the relative atomic mass. تعالي نشوف كده. بيقول لي deduce the relative atomic mass of the element rubidium from the data given in figure 2.7. ايه الروبيديان بيقول لي ها؟
It's gonna be easy. Okay, so first thing that we see is that its mass chart, we have two ions, two isotopes, sorry. One of them is 85 with an abundance of 77. The other one is 87 with an abundance of 23. So what we do is we just do 85 times, I'm just gonna divide it by 100 على طول, so I don't have to divide it by 100 later. 85 times 0.77 plus 87 times 0.23, and you get an average of 85.46.
بالظبط كده. طيب boron exists in two isotopic forms, boron 10 and boron 11. Boron 10 is used as a control for nuclear reactors. Use your periodic table to find the abundances of the two isotopes. What would you do? What
Okay,
would you do?
B10. Okay.
اولا نبص على البيريودك تيبل to get الايه؟
Oh,
الريلاتيف
yeah.
الريلاتيف اتوميك ماس بتاعه هيطلع
So
بكام؟
boron is, where's boron? Okay, it's 10.811.
10.811. ماشي. So we can say that in boron 10
Mm-hmm.
times its percentage of الابundance مش كده؟
But we don't have that.
let it be x اديني فرصتي. let it be x.
Oh, فهمت. عارفة.
طيب قولي اعمل ايه تاني؟
Okay. So we do 10 times x plus 11 times x
لا بقى مش 11 times x بقى.
equals
خدي بالك ما هي الاكس دي هتبقى البرسنتج بتاعته صح كده؟ قولي مثلا لو انا قلت 30
y times
يبقى
y.
بلاش واي، ما انت بخلي فيه 1 فاريبل عشان تعرفي تجيبيه.
But we
ليه
don't
ما
have 11.
نقولش 100 ماينس اكس
Okay.
عشان يبقى 70 مثلا؟ يعني لو ده 30 يبقى اكيد ده 70.
Mm.
اوكي. والكلام ده كله بعد ما اجيبه هقوم جاي اسمه على 100 عشان خاطر يديني اللي موجود في البيريودك تيبل اللي هو ايه؟ اللي
10.8.
هو 10.80 811. خدت بالك من
Oh,
الفكره؟
yeah.
يبقى little x atoms be boron 10 atoms, the remaining
Mm-hmm.
atoms are boron 11.
Mm-hmm.
طبعا consider a sample 100 atoms. فاللي انا هعمله بقى ايه؟ هقول ان ال x times 10 اللي احنا عملناها هنا اهو plus 100 minus x times 11 هيساوي كام؟ نشتغلهم. x times 10 ب 10x.
Mm-hmm.
طيب وال 11 دي هضربها في الايه؟ هضربها في ال two values inside the bracket يبقى 11 times 100 ب 1100.
صح.
صح كده؟ وبعد كده 11 times negative x بنيجاتيف x. اوكي.
Mm-hmm.
طب وبعدين انا عندي 10x وعندي minus 11x يبقى 100 1100 minus 1x لان دول هيروحوا مع بعض.
Right.
يبقى انا الفاليو اللي انا جبتها دي ال 110 minus x دي هقوم جاي قاسمها على ايه؟ يبقى هقول كده ماينس اكس الكلام ده كله اوفر 100 المفروض يطلع لي ب 10.811.
Okay.
اقوم جاي مطلع ال 100 هنا يبقى
Right.
1100 ماينس اكس يساوي، هضرب ال 100 في الرقم ده هيطلع مثلا بايه؟ ب 10.81.1. وبعد كده اودي ده هناك بالنيجاتيف فهيطلع نيجاتيف اكس يساوي مثلا 81 ماينس 100 هيبقى 19 مثلا. فالاكس هتساوي دي بالنيجاتيف فالاكس هتساوي 90.
Mm-hmm.
جبت انا
Okay, فهمت.
الاكس
Yeah.
انا كده جبت الاكس.
You found x, but now you have to find for 11, so you do 10 minus 19.
يبقى
What did
كأن
you get?
ما هو عايز ايه في الاخر؟ use the predictable to find the abundances. فالاكس دي الاباندنس بتاعت
One of them.
one of them اللي هي قلنا let it be في الاول ان هي بورون 10.
Hmm.
فهقول ان البورون 10 والله ده موجود بنسبة 19%. يبقى بورون 11 هيبقى بنسبة 100 minus 19
All right. 81.
هيبقى 81. اوكي.
Okay.
طب هاو دو اي نو ان انا كوريكت؟ خدي بالك لو كان الاباندنس بتاع البورون 10 اكتر من الاباندنس بتاع بورون 11 ما كانش هيبقى الريلاتيف اتوميك ماس اللي بتاعهم ده نير ال 11. خدي بالك ده 10.8، لو عملتي راوندنج هيبقى 11.
Mm.
مش ممكن لما تعملي راوندنج يبقى 10. ف this
Right.
means ان I will find that ان البورون 11 is more than البورون 10.
Mm-hmm.
لو كان مثلا طالع لي 10.1 مثلا
Mm-hmm.
that
Okay, great.
means ان البرسنتج اوف الايرن البورون 10 will be more than البرسنتج اوف البورون 11. خدتي بالك؟
Yeah.
This is a good question.
This was fun. This
This was
this part
fun.
here was easy and quick and fun. I like this part.
وخلاص وخلص كده، مش هناخد حاجه في الماس سبيكترم غير كده. خدي لي بقى الهوم ورك ده بالمره. احنا
Okay.
كده بوك المره اللي جايه يوم الاحد ان شاء الله. ولو عايزه الاديشنال بارت ده نشوف ايه الحاجات اللي انت ناقصاكي في الاول اوف ذا بارتس ونعملها مع بعض. احنا كده يعتبر جاهزين للاكزام از ستارتر يعني. خدي بس
Mm.
خدي بيكتشر كده.
Took the screenshot, yeah.
ايوه.
Yeah.
بس please do the homework
Okay.
before Sunday عشان لو في حاجه في الهوم ورك is not clear نعملها مع بعض.
Okay.
وساندي نشوف انت عايزه تعملي ايه نعمله، مفيش مشكله خالص.
All right, perfect. Thank you so much.
شكرا شكرا شكرا.
Thank you. See you on Sunday.
See you.
Bye.
Bye.